Okie dokie. So today we're talking about the power rule, and from the last example of the derivative, I solved this one in my head right away, so now I'm going to show you how to do that. In my calculus class, the teacher had to struggle through it for about 3 weeks of calculus without knowing how to do it. But here I'm just going to show you the day later. Okay, so what we're going to use is called the power rule, and I'm going to write the rule here. So dy dx, actually d over dx, is x to the n, and so the derivative equals n times x to the n minus 1. This is the rule. So what does that actually mean? So we're going to take the example from yesterday, this x cubed plus 2x, and we're going to do that. Now, we'll get into more rules about derivatives later, but because they're adding, the derivative of one number plus the derivative of the one number is the derivative of the two numbers. So we can just do the derivative of each single term and move it down. Okay, so the derivative of x cubed, so we're going to take 3, move it to the front, so 3, move our exponent down, and then 3 minus 1 is 2. And then we're going to add the next term, so x is to the first power, so that becomes 2. And this is x to the first, which 1 minus 1 is 0, so we're going to have a 0 in the exponent, and x to the 0 is going to equal 1, and 1 times 2 still equals 2, so that's why we're writing the 2 right there. And that's all it took to get, instead of this long process to get 3x squared plus 2, that was it. So now I want to do two other examples, that because things can get kind of tricky, so you have to remember your powers rule, or rules of exponents. So first we're going to look at this one. So what would the derivative of this be? I would change it into x to the 1/2, and then we just do the same thing. So we're going to move it 1/2, put our x on there. 1/2 minus 1 is going to equal negative 1/2. So x is to the negative 1/2 power. And so if you wanted to simplify this, it would become 1 over 2x to the 1/2 power, or that could also be written as 1 over 2 root x, either way. So kind of more of an involved process, but still the same idea. We're going to look at the exponent. We're going to move the exponent into the coefficient spot, subtract n minus 1, and then the rest is just cleaning it up. One more example I want to look at is 1 over x squared. This example still is pretty similar, so it's 1 times x to the negative 2, because the negative is what puts it on the bottom of the denominator for powers. So we move the 2 to the front, negative 2x, and then negative 2 minus 1 is negative 3. So negative 2 minus 1 equals negative 3. And so we could clean this up, so negative 2 on top over x cubed on the bottom. That would be our final thing. And I hope that was helpful.